Alright, let's begin. So for this video, we had to do the capture the flag with turn-based movements. So both sides will be starting off by flipping a coin, and then the value from that coin determines who gets to move. So if both coins are the same, then the client creates its move packet and sends it over to the server. Both sides will advance the client player. If they are not the same, then the server will create its move and send it over to the client, and both sides will move the server piece. After that, both sides will update the field and check for a winner before repeating the loop until a winner is found. The move strut has a movement value, a direction, and a player. So then we have the associated serialize and deserialize to get all of this data. Additionally, the action call will be done based off of a given player. So player 1 will move player 1, player 2 will move player 2. And capture the flag also has that enum for the player and a coin enum as well for the heads and tails. For the values inside the sending and receiving of packages, both sides are done pretty much the same. So both sides can send and receive coins. So both of them can send and receive them. I'm just going to use one side for this. So both can send and receive coins. They are indexed with a packet number to help prevent duplicates. When you send over a message, you will construct a packet, which is handled based off of which of the message types we are working with, and then send it on over with a chance of duplication. If the type you're sending is not an ACK, you have to wait for an ACK before moving on. So that will be in the receive call. So for receives, you loop through receiving until you find a packet whose index is not the same as the last accepted packet. This is where that packet number index helps prevent duplicates. So once you find a unique packet, you can break out of this loop and extract the data from it. Extracting the data will update what the last index was and increment the packet number so the future index that you send will be up to date. And then, yeah, that's where you do all your necessary mem copies as well for the data to be deserialized. And then, once again, for receiving, if you receive something that is not an ACK, you have to send an ACK to the other side because they will be waiting for that before moving on. And that lets you break out. That's it for that. Let me just quickly showcase that the client side is the same. So once again, you send the messages, build the packet, send it over. If it's not a type of ACK, wait for an ACK before continuing. Building based off of the different types, receiving, looping until you find a unique ID, extracting the packet over here based off of what type it is, and then if the type you received is not an ACK, you have to send an ACK before continuing. For the C# assignment, here, let me just quickly scroll through this. So for the C#, for the calculator, we have these associated different functions as well as the enum. For the FSM, we have the same thing except for states. I did not have time to do the proper states, so all of these are using an ugly switch statement. For calc data, we get the current calculator and call the associated function based off of the request that was stored inside the data. Same thing goes for the FSM, where we check which type of data we are looking for. If it's advanced, we call the advanced call. Otherwise, we call the set call. And then lastly, for the input queue, we add messages onto the queue. And then when it's time to process them, we loop through and do the associated work. So messaging is just a base class that has the do work function inside of it. Both the FSM data and the calc data derive from it, and their do work just calls the execute request that I showcased earlier. So calc execute request does the given function, and FSM do execute request will just do either advance or set depending on what was it told. And